In section 11.4, we need to just understand a little bit. Basically, we need to understand this diagram. And so I suggest you just follow it with me here on the slide, okay? You will not be asked to do calculations based on this, but you might get conceptual questions on this. So this diagram is going to show us what happens to water as it changes phase. And we're going to start with a bucket of ice at minus 30 degrees. Okay, so where we start, we have a temperature of minus 30 degrees Celsius. Okay, so it's ice, all ice. And on this axis, we're going to now start providing energy into the system, right? So effectively warming up the ice. And we're going to continue to do that all along the horizontal x-axis. So if you look at the x-axis, we start at 0, no heat is going in, and then more and more heat is going in, and this is how time is proceeding also, okay? So energy is added in joules continually, and we're just going to watch what happens to the system. So what do you think happens when ice is at minus 30 degrees and I add positive Q in? We're going to use Q equals mc delta T. We have a certain mass of ice. It has a given specific heat, and there will be a temperature change, right? Until ice reaches 0 degrees. So here's the temperature changing with added energy, right? Till we reach 0 degrees. So you understand this first sloping line. Yeah? At 0 degrees, we have reached the melting point of ice, right? Now, until all the ice melts, all the energy that goes in, the Q that's continually going in, is now going in to melt the ice. It no longer causes a temperature change until all the ice has melted. So where we find B, we have a 0 slope, there's no change in temperature, and as we're adding more and more energy, we're going to the right of this line, more ice is being converted into water. So here we begin to have an ice-water mixture, more water, less ice, more water, less ice, more water, less ice, and entirely water, right? After we've given in, say, 396 joules worth of energy, okay? You don't need to memorize any of these numbers. You need to understand the difference between the horizontal lines where you have the line is flat and the slope is 0, and the lines where you have a positive slope. Now you have all water in the system. You don't have any ice at this point. And you're beginning to continue to warm the water now. So water is going to increase in temperature, right? You're going to apply a Q equals mc delta T now to the water system. So it's going to start warming up, and it'll keep warming up till water starts becoming vapor, right? So water vapor gets formed at 100 degrees Celsius. So at 100 degrees Celsius, we have our next phase change, okay? We change from the phase of liquid water to steam. So we begin to get steam, and now until all the water becomes steam, all the value Q that's going in is now going in just to change the phase. There's no further temperature change until all the water evaporates. So that's what's happening in D. And you can see how much more energy is required to evaporate all that water, right? As compared to the energy required to go from ice to water. We haven't increased the amount of substance. It's the same amount of substance. We haven't added any water to the system or any ice to the system from the start. Once you reach 100 degrees Celsius and all your water has turned to steam, you are at this point. Now, at this point, you had 100 degrees Celsius, everything is water. Some part water, mostly water, some steam, about 50-50 water and steam, less water, more steam, all steam. That's how you're progressing along this line. Once you have steam at 100 degrees Celsius, if you continue to provide energy into the system, you're not going to get superheated steam, which is this portion E of the line going upwards, very steep slope. You begin to get superheated steam. So this is all that I need you to do for section 11.4. You need to understand this graph. You need to be able to explain it like I did to you. Okay? Thank you.